everyone, my name is Sajith. This is my TN565 project. In this project, I'm going to talk about data centers. In this video, I'm going to explain about the data center, then what kind of data centers do we have and how do we run data centers. Before I going to talk about deep details about data centers, I would like to explain what is a data center is. A data center is a physical faculty that small or large organizations use to store their critical applications and data. Its design is based on a network of computing and storage resources that enable the delivery of shared applications and data. The key components of data center design include routers, switches, firewalls, storage systems, servers, and application delivery controls. Nowadays, a data center is really essential for the businesses because they use the data centers for their email and file sharing, virtual desktops, communication and collaboration services, customer relationship management, productivity applications, big data, artificial intelligence and machine learning, enterprise resource plannings and databases. Now we need to know how data center operates. There are two main operations in data centers. Data center services are typically deployed to protect the performance and integrity of the core data center components. The first one is network security appliance. This includes firewalls and intrusion protection to safeguard the data center. The second one is application delivery assurance. It is to maintain application performance. These mechanisms provide application resiliency and availability via automatic failover and load balancing. The stance of the data center is very essential to understand how the quality of the services. The most widely adopted stand for the data center design and data center infrastructure is TIA 942. There are four categories of data center tiers related four levels of redundancy and fault tolerance. Those four tiers are basic site infrastructure, redundant capacity component site infrastructure, concurrently maintainable site infrastructure, fault-tolerant site infrastructure. Okay, let's go and talk about the first one, the tier 1. The data center offers limited protection against physical events. It has single capacity components and single non-redundancy distribution path. The second one, the tier 2. This data center offers improved protection against physical events. It has redundant capacity components and single non-redundant distribution path. The third one, the tier 3. This data center protects against virtually all physical events, providing redundant capacity components and multiple independent distribution paths. Each components can be removed or replaced with distributing services to end users. The fourth one, tier 4. This data center provides the highest level of fault tolerance and redundancy. Redundant capacity components and multiple independent distribution paths enable concurrently maintainability and one fault anywhere in the installation without causing downtime. Now I'm going to explain about types of data centers. I'm going to talk about six main types. The first one is enterprise data center. The second one is colocation, sometimes we call colo. Third one is computer rooms, then computer closets, telecom closet or patch room, then cloud data centers. The first one, enterprise data center. Normally this one used by the large faculty. The purpose built for housing computing equipments, usually a dedicated building but sometimes a floor of a building. The second one is colocation. In colocation, sometimes we call colo, data centers. A company rents space within a data center owned by other and located off company premises. This colocation data center hosts the infrastructures, building, cooling, bandwidth, security, and etc. While the company provides and manages the components including servers, storages, and firewalls. The third one is computer rooms. Normally, this is for the small businesses. It's a single room in an office building. The fourth one is computer closets. That's for the small business too. is a small closet, usually large enough for one rack. A telecom closet or bedroom, a small closet with cross-connection wires, no active equipments or coolings. Sometimes they call the dark room. The last one is cloud data center. In this off-premise from a data center, data and applications are hosted by cloud services providers such as Amazon websites, Microsoft, or IBM Cloud, or another public cloud providers. When we are thinking about a data center for our business, we can have more decisions. Thinking about our services, our budget, and our size of our business, we can have some decisions. The first one is building, then second one is renting, third one is outsourcing, the fourth one is no data center, or we can have hybrid. The first one is building. Building and managing a data center is not an easy process because it is expensive and needs staff with skills. Reliability and availability are the most important features that are coming without a deep understanding of each technology. Data center requires the specialists on power system, HVAC, data center designing, networking, facility management, and service architecture and data center operations. Building a data center mostly used by large companies because building a data center is cheaper than renting for their business. In this case, they are controlling and analyzes the whole processes. With this situation, they can bring down the cost and find other efficiencies. It is called vertical integration. The second decision I'm going to explain is renting. Most small companies renting data centers. It is cheaper to take colocation facility for them rather than building one. Normally they are renting a cage or a specific number of racks. The tenant provides reliable condition power, high vac, power suppressions, and racks. The company is responsible for managing and allocation and operations. The third decision is outsourcing. Data center outsourcing, we call DCO, is a practice of partially or fully outsourcing IT infrastructure and hosting management from a third-party data center. The main goal of DCO is to provide top-tier hosting equipment and staff members that clients do not have on an in-house level due to financial constraints or strategic budgeting. Next one is no data center. Some companies are not worried about space for the data center because they are using web-based applications. Those web-based applications providers are known as SaaS, Software as a Service. BigCommerce, Google Apps, Salesforce, Dropbox, Mailchimp, Zendesk, DocuSign, Slack, HubSpot are some of examples for software as a service. These companies develop the application and they maintain them. The last one is hybrid. It is common to see a mixture of these old strategies. A large global company may build large regional hub data center in a few strategic locations around the world, but include a small computer room in each office that hold network equipments and servers that provide local services. A medium-sized company may rent colo space or buy IaaS services, plus use SaaS-based applications. Small companies may rely entirely on software as a service based applications, and in turn need only small computers closet for their network equipments. When we are planning a data center, our decision should be based on our services and on its requirements. There are two kinds of requirements. There are business requirements and technical requirements. Here I'm going to explain about business requirements. When we are thinking about the business requirements, it is different companies to company. For an example, small companies need to keep their book records and run some applications such as email, printing, and scanning. But in large organizations, this situation is different because they have many requirements, like different departments have different requirements, privacy and access controls, and etc. In business requirements, there are some subsections that we have to focus on. They are availability, business continuity, budget, change control, regulatory constraints, data privacy, and flexibility. Availability, we can describe what reliable services need to continue their process. We can find the solution to answering of following questions. Which time zone are the people accessing the service going to be in? Will the service experience near constant load, or will there be a peak usage times? What kind of service level agreements required? Does that differ from peak usage times? Cloud providers are typically better able to specify, monitor, and maintain an SLA than a small in-house team. Next one is business continuity. It is focused on requirements. Does the company has to operate or return to operational status in case of an outage? The budget is about the available money the can company spend on IT. The change control is about what extent does the company need to control when IT changes happen, and how much change can happen at once. Does the company need to be able to define freeze period, preventing changes from happening or promote stability during business critical time periods? The regulatory constraints are about which regulations apply to company that impact IT decisions. The data privacy is about which additional data privacy requirements the company has. Even when local laws do not apply, company may have internal policies that respect to the exposure to certain data and third parties. The flexibility is about company's computing needs. Does the company need availability to rapidly scale up and down again in its response events? When we talk about technical requirements, they are essential for the business requirements because they need to keep processing. There are some features on the technical requirements that we have to focus on. The first one is services and applications, then update frequencies, security, remote access, custom access, responsiveness, and capacity are some of those technical requirements. Service and applications are focusing on which services and application does the company need to run, and which facility do it require. Most companies will need basic services such as authentication, DNS, DSCP, email, printing, phones, calendaring, meeting softwares, file sharing, backups, and so on. The update frequency is about how to up-to-date the application and operating system installations need to be. How quick do we need these features to available to end users? Next one is security. It is really important in a data center. Security is what security requirements does the company have. At a minimum, all companies need to patch security flaws and implement anti-malware measures. The remote access is focusing on users' need to be able to access any or all of the service remotely. For example, some people may need access while traveling on the business. A sales team may spend more time on their working from remote customers' locations and may in remote access the key sales applications. Customer access identifies which services need to be available to customers. Responsiveness is how responsive each application needs to be and the capacity to analyze how many simulations uses or transactions per second in each application need to be available, handled, and what is expected to change over time. After we build a data center, the important process is managing and maintaining the data center. This includes monitoring and managing the capacity. In this process, we are ensuring that there is enough space, power, cooling system, and repairs and maintenance. Data center capacity management is a broad process that includes all the process tools and methodologies to manage the process of data center capacity planning, designing, and implementations. It is an IT capacity management process that routinely reviews, analyzes, and plans for capacity planning within a data center. Typically, the data center capacity management requires a formal design of a data center capacity plan. This management ensures that the capacity plan is implemented and the entire infrastructure is routinely analyzed for any improvements or optimizations. It can also automated through process build software that analyzes the current infrastructure with ongoing and future computing requirements. In addition to core computing resources, the data center capacity management also analyzes non-functional components for future needs, such as power and cooling infrastructures and the overall data center flow spaces too. It is a part of the data center interaction management process. In this video, I'm going to explain some details about rack space, power, and wiring. Tracking rack space is one of the many tasks for which having standard hardware types and an up-to-date inventory system make us work much easier. Associate each asset in the inventory database with standard hardware type which has certain dimensions. Also put each rack into inventory database associated with its standard type which has certain dimensions. Give each rack a location and optionally a zone or other multi-data and constraints its usage. When the data center is built, the power system will be sized based on the typical power consumption per square meter for a data center. However, over time, this number of changes. Machines get smaller, so more we can fit in the same space, therefore increasing the total power consumption. Machines get more efficient, consuming less power than previous generations, reducing the total power consumption. So is our power consumption going up or down? That's what we need to understand. Probably it's going up because in the same space we are going to insert more equipments. How we can understand that? That's why we need to analyze our power consumption. If we don't track our power consumption, we don't know how much we are consuming, then we can have more serious troubles. Therefore, tracking power and the management of power system is really important for a data center. Most data centers will have some amount of wiring infrastructures. For example, each rack may have a patch panel. At the top of that is wired back to the central network row, like power. The wiring infrastructure is a resource that should be actively managed. Data center usually use three main kind of networking cables: AC/DC power, ground copper, and fiber optic. To determine which type of cabling using get equipped, we may refer to the interface available on the equipment used in the data center. Additionally, we may also determine specific network data cabling needs based on the data center equipment's bandwidth requirements. Data center cabling may fall under either two categories. The first one is structured, the second one is unstructured. When predefined standard based on design, with preset of connection points and pathway are employed, each follows the structured cabling design. Specifically, structured cabling enforces a cabling design based on the bandwidth requirements on the system. After testing to ensure good performance, the cables will then get organized and labeled. While the structured cabling system may take longer to install and may pose higher cost, but in the long run the operational cost will significantly be lower, and the system lifespan will remarkably be longer than the unstructured approach. The connectivity provided by cabling infrastructure is foundation of every data center, enabling transactions that help business make mission-critical decisions every day. All data centers have various cabling types, ranging from all copper installation to all fiber installation, and everything in between. Whether the cable is questioned for power or data, failure to properly manage this critical part of the data center infrastructure can cause serious issues, from increased operational cost, more expensive outages. Cable management cannot be an afterthought. To get data center cabling right, like many other life practices, through team planning and thinking through the installation and advance is always best. Simultaneously designing a cable infrastructure and the data center using system requirements and physical layout to ascertain the type of the quantities of cable need might to be the optimum solution to the data center cabling. The time spent planning on infrastructure will save time. When we plan the infrastructure out, we don't have to waste time identifying which equipment is connected to which cable for troubleshooting, repair, or replacement in the future. Installing best practices are testing and certification. That's for ensure that interfaces is working and will support our bandwidth and system needs. Then documentation to record the type of the cables used and the locations and connection of each cable to each feature troubleshooting for maintenance. Measure to ensure that the cable are proper length. These measurements prevent unforeseen downtime for critical IT equipment caused by loose wires getting lent or disconnected. Growth plan. Make sure our system is participate for the foreseeable future. Ensure that tracks and cables trays get designed to accommodate anticipate growth. Organization best practices are run cables to the side of server rack to ease adding or removing servers from the shelf. Bundle cables together to connectively connect to the next piece of hardware down to the flow in data centers with equated flow or up to ceiling data centers with wiring that run through the ceiling. Label cables securely on each end. This labeling process enable us to conveniently locate cable for testing or repair, install new equipment, or remove extra cables after equipment has been removed or upgraded, which save time and money. Color codes cable for quick identification. Choose a color scheme that work for us and our team. If may be wise, put a length significantly the meaning of the colors of each cable. We may also color code the cable's destination, especially for the large installation across floor or offices. Here I'm going to talk about the life cycle of data center. Day-to-day data center operations revolves around the life cycle of the computer equipment within that data center. The life cycle of data center equipment starts with installation, which are followed by series of moves, adds, changes, and some maintenance works. Eventually, the equipment of the decommission. When these data center processes are all based around the inventory system, the data center is each easier to manage. There are some steps of the data cycle management. The first one is identify, the second one is design, the third one is building, the fourth one is operate, and the last one is decommission. Identify. The beginning of any data center's life starts with finding a location that meets the client's need. Find the potential locations, accessing the availability of power and network connectivity. For plan analysis, airline flight path review, and just few of these key areas that need to fully investigated as a part of site selection. Design. When we have identified one or more potential locations, it is important to draft up to design for the building. Having a view understanding of client requirements allow designs to be created that fits the site and the surrounding area. It's more than just number of racks and amount of powers, resilience, flow load, efficiency, renewable power, locate restrictions are just few of important items to consider before proceed with any plan applications. In parallel to the planning applications, work can be proceed on identify our construction partner, reviewing and updating our budget and creating a construction and fit out our project plans. The next step is build the data center. It is really important to complete by experienced and reliable partners. Close management of the construction plan with all parties is the key ensure build completes of time and on the budget. Any issues, delays or budget overrun need to be addressed promptly to avoid delays to get completion dates. As construction takes place, detailed design and planning work can be completed for the interior fit-out. Uninterrupted access to the energy is the alpha and omega of a data center. That is why data centers are built and why they should be ideally powered by two independent routes of energy coming through their own transformers. The energy goes to substation through automatic transfer switch, that's called APS, with a diesel generator connected, and into the UPS units with their own battery modules. Small companies can make do with only one substation, but every machine should be dual powered through two independent routes. Large data centers who expected to use more than 2 megawatts can meanwhile switch up to the UPS with batteries and go for unique battery less power solutions. The so-called dynamic or rotary UPS. These combined a transformer, a UPS and a motor generator in one pack. Is work bit like a flywheel in a vacuum case that is spinning endlessly and can convert in stored energy through generator into critical electric energy when needed. A unnecessary part of a data center is its cooling. A de facto stand is a double flooring and system of cold and hot aisles. The cold aisle should be roofed over the prevented the mixing of hot and cold air. The server racks need to be placed in a specific way. They should inhale the cold air from their front aisle and exhale its hot out their back. The double flooring mentioned allows the cold air to be led into the correct place and also hide the metallic cables. Optical fibers should probably to be led up over the rack in a special plastic through. Then our servers need to be protected not only against energy outage but also against fire and on unauthorized access. Even the small server room should have at least fire alarm and fire extinguishers for electric appliances. Medium-sized data centers usually employ automatic fire and heat detection systems, and the fire part of out through insert gases. Example, ecological FM200 that is the safe for both servers and environment. There are of course cheaper alternative using for example demineralized water or sodiums. The next step is operate. The operation of our data center can rely to be divided into three main phases. The first one is pre-go live testing, the second one is normal operation or BAU, the third one is updated and enhancements. The first one, pre-go live testing, it is completion of build and core services delivery. A full building integrated system test must be completed. The second one is normal operation or BAU. Its initial deployments are likely to be classified as active fit-out. These effectively are the core infrastructure services that supports our servers, applications, and etc. For example, network storage, IAM, and monitoring. Installation of application servers and migration of business data. BAU operation will see new servers and services deployed, managed, upgraded, and decommissioned. Change and capacity management are key of ensuring that data centers runs smoothly and efficiently. Real-time monitoring of our data center is critical. Infrastructures and the servers and services within critical to identify issues early, addressing such as issues quickly, enable from them to be addressed safely with minimal impact to live services. Upgrade and enhancements. Most data centers have useful working life of 10 years as a minimum. Look after data center can support the IT needs of its clients for far long period. However, we all know that the pace of change that with technology today means that it's inevitable that updates and enhancements will be required during the data center lifespan. This could be simple replacement of chillers or AC units, increase in power density, to name a few. A few managed data centers mean planning and executing these upgrades and enhancements can be completed quicker and with less risk of our business. Decommissioning. This is the last step of lifecycle management in a data center. When technology get advanced or equipment get upgraded with new technologies, it is great to will lead the decision to exit decommission our facility. Once decision is made, understand the option to how we migrate our business services and data out of our DC and into new target locations safely and securing is critical. But then we need to decommission our supporting infrastructure services, building applications, and complete the building decommissioning processes. In this presentation, I explained about the data centers, like what is the data center is and the type of data centers and what kind of decision we can make for the data centers, and also I explained what are the business and technical requirements. At the end, I explained some details about lifecycle management. I hope you guys learned something through this video. Thank you.